Simplify each expression. We have 36a to the 5th b squared over 6ab to the 7th, 32c to the 5th d over 42c to the 4th d to the 9th, and 15f5g to the 4th over 30f squared g to the 6th. How am I going to simplify each of these rational expressions? Chloe is here with her latest cheat sheet notes. She wants you to know that when you are looking for domain restrictions, you cannot have a 0 as the denominator. Also, any value of x that causes the denominator to equal 0 is definitely restricted. Also, when you're dividing by same bases, you subtract the exponents. Now that we have Chloe's cheat sheet notes, we can go ahead and simplify each of these rational expressions. On this first one, we have 36a to the 5th b squared over 6ab to the 7th. I noticed that my a doesn't have an exponent, so I'm actually going to write the 1 in there because there is an exponent of 1, we just don't write it. And for me to see the exponents, it helps me to make sure I don't make a mistake. Now from here, I'm going to go ahead and reduce things in the numerator and denominator. 36 and 6 can both be reduced by 6. 36 divided by 6 is 6. 6 divided by 6 is 1. And if you look down here at Chloe's cheat sheet notes, she let us know when you're dividing the same bases, you have to subtract the exponents. So notice that we have a to the 5th and a to the 1st. They both have the base of a, so we can subtract these exponents from each other, 5 minus 1. And since 5 is the bigger exponent, we're going to keep a in the numerator. Then on this other one, we have b squared over b to the 7th. b is the same base, so we're going to go ahead and subtract those exponents, 7 minus 2. Because 7 is the bigger exponent, we're going to keep the b in the denominator. So we have here 6 over 1, and then we have our a, 5 minus 1, over our b, 7 minus 2. So we just took that same base, subtracted them from each other. The exponents are subtracted from each other, and we keep the base wherever the bigger number was. Then from here, we can go ahead and reduce this to 6a to the 4th, b to the 5th. Now let's look at the second one. In this problem right here, we have the same thing that was going on in the first problem. We do not have an exponent on the d. So I'm going to go ahead and write in that 1 because that helps me out a lot. Now I'm going to see what can I reduce between my numbers, 32 and 21. Well, 32 divided by 2 is 16. 42 divided by 2 is 21. Then I'm going to look at my variables. I have c to the 5th and c to the 4th on this next one. Now, since 5 is bigger than 4, c will remain in the numerator, and we're going to subtract 5 minus 4. d to the 1st and d to the 9th. Since 9 is bigger than 1, d will stay in the denominator, and we'll subtract 9 minus 1 there. So you can see I have 16 over 21, c to the 5 minus 4 in the numerator because 5 was bigger than 4, and d to the 9 minus 1 in the denominator because 9 was bigger than 1. From here, we can go ahead and reduce that to 16c to the 1st over 21d to the 8th, and we don't really write that 1 when there's an exponent of 1, so we can take off that 1 and get our final answer of 16c over 22d to the 8th. Now on our last problem here, we can see we have 15 and 30 that can both be reduced by 15. 15 divided by 15 is 1, 30 divided by 15 is 2. F to the 5th and f squared, they both have the same base, so we're going to subtract 5 minus 2. Since 5 is bigger than 2, we're going to go ahead and keep the f in the numerator. And then on the g part, we have g to the 4th over g to the 6th. So we will subtract 6 minus 4, and we'll keep the g in the denominator because 6 is greater than 4. So we have 15 canceled out to equal 1. So we have f 5 minus 2 over 2 to the g to the 6 minus 4 power. Then we can go ahead and reduce that, and we get our final answer as f cubed over 2g squared.